Okay, today we're looking at 3.3, and our goal is I can use the discriminant to determine the number and kinds of roots. Now, in your textbook, they call it real roots of quadratics, but what we're really looking at is a special thing called a discriminant. For those that took 2D last year, you talked a little bit about the discriminant. So first of all, we're talking about nature of roots. So in other words, what they are. Okay, so when we solve quadratic equations, okay, whether it's by factoring or the quadratic formula, we are finding its roots. We also call them the zeros. It's also the x-intercepts. Now, there are three possibilities for x-intercepts or for these roots. Okay, one is imaginary. In other words, they never cross the x-axis. So what that means when we talk about imaginary, it means that if I have my axes here, which I'm going to create, and I'm going to actually clone it and use it a few times. So I'm just going to put it over here and group it so we have it. Okay, so what happens here when it never crosses the x-axis, all it means is that parabola is actually going either up above the x-axis or down below the x-axis. Okay, so it just means that the function, the quadratic, doesn't cross the x-axis. It doesn't mean that the parabola doesn't exist when you graph it. It just means that it won't cross that x-axis. The other kind means that we have what we call real and distinct, distinct meaning different, and it means that it crosses the x-axis at 2 points. So if I take this, and I'm going to clone it and bring it down here, what happens in this case, it just means that the parabola will cross at 2 places. Okay, 2 different places. You can see this one's a negative one and this is a positive one. And again, it could open downward and create the same thing. And the other kind is what we call real and equal. So in other words, it crosses the x-axis at 1 point. So really what it's saying is the vertex is right on the x-axis. So it just means the vertex just touches it at one place, so its vertex is there. Okay, so again, it can open down, it can open up, but what happens is its vertex is just on the x-axis, just in one spot there. Okay, so how can we tell without graphing and without actually using the quadratic formula? Because that can be pretty tedious and time consuming. Well, we use a thing called the discriminant. It discriminates between what kind of roots, what kind of x intercepts we have, or if we have any at all. So the discriminant is denoted by the letter D, is the value underneath the square root of the quadratic formula. So that would mean that it would be this. So D equals B squared minus 4AC. Notice there isn't a square root around this. Okay, so this is a little mini formula called the discriminant, and it tells us a lot of information. So when I substitute values into this, my B, A, and C, it will tell me, first of all, for some reason that doesn't want to show, fade out maybe, there it is. When D is less than 0. So in other words, when it's negative, so when we have a negative here, it means the roots are imaginary. So it would be taking a square root of a negative number. And you know that that's impossible. So if the value of D is negative, we know it's imaginary. If, and for some reason, all of these are going to do this. If D is greater than 0, in other words, if it's a positive number, the roots are real and distinct. It means it crosses the x-axis in 2 places. And finally, the last one tells us that if D is 0, then the roots are real and equal. In other words, the vertex is right on the x-axis. So let's take a little closer look at how we would do this. Okay, so here I have my equation and I want to determine the discriminant. Well, again, what I do is I take and I actually use the little formula to figure out what it would be. So I don't have to use the whole quadratic formula to do this. again, all I have to do is take the discriminant, and the discriminant equals b squared minus 4ac. I can see my a here is 1, my b is -6, and my c is 5. So I'm going to substitute these values into our formula, and we would end up with -6 squared, which will come out as a positive answer, 4 times 1 times 5. So when I do that, I end up with 36 minus 4 times 1 times 5, which would be 20. So I end up with 16. So according to the last page, because this number is greater than 0, okay, so D here is greater than 0, it means I should have two real distinct roots. And remember, distinct stands for different. And actually what I've done to the side here is I actually have the actual graph of it, and I'm just going to bring it up so you can actually see, and you can put yours over top if you so wish. You can see that it crosses in two places. It crosses here. I'll just bring up the red. So it crosses here. Oops, sorry, wrong spot. Crosses here. Here's the x-axis, and it crosses here. Oh, actually, I think maybe I always think I was right. Or here and here. I think it's there and there. Sorry about that. So what we have then, when I put it back in the right spot, there's our y, here's our x. No, it's not. That's mine from behind. Oops. Get out of there. I'm just going to unlock mine and get rid of it because I cannot see what it's doing. Unlock, and let's delete it. I'm going to put the actual real one here. So this is our x, and this I'm going to unlock and actually move it where the y is. Now I can see exactly where it is. So here it's located here and here. You can see two different numbers it crosses. Okay, let's do the next one. Hopefully I don't have as much difficulty with it. And actually I think maybe what I'll do is I'm going to unlock some of these now so that they are out of our way when we go to do this, and it will be gone for good. Goodbye. All right, so the next one, again, I'm going to use the discriminant, and so I'm going to determine what I have here. So this time I will use blue. My A is 1, my B is -6, and my C is 9. Again, my discriminant equals B squared minus 4AC, and substituting those values in, I end up again with a -6 squared minus 4 times 1 times 9. And this time what I end up with a 36 minus a 36, which equals 0. Okay, so in this case I have D equaling 0. So they should be two real and equal roots. Now the reason we say we have two of them is because it is a perfect square actually. If I took this number here, and I could actually, this is what this would be. So there's two brackets that are identical. So that's why it says two real, even though if we take the picture here and look at it, you'll see that it is, you don't necessarily see that. You see that it crosses in one location, which is right here. It actually crosses at 3. Ah, amazing. X equals 3. We've got it at 3. Okay, so let's do the last kind now. So the last kind, again, I'm going to have my A, B, and C, and I'm just going to get rid of these again in a second. And let's go and do this. So we would have, we'll do green again. We have A equals 1, B equals -6, and C equals +12. If you notice, I'm not changing these numbers in here that much, but just enough to change where the the parabola would cross the x-axis. So again, let's do discriminant equals b squared minus 4ac. We would have negative 6 again squared minus 4 times 1 times our 12. So we would have a 36, take away a 48, and we would have a negative 12. Now obviously in this case d is less than 0, so it's a negative number. So according to that I should have imaginary roots. And what that means, it doesn't mean that the parabola doesn't exist, it's imaginary. It just means that the parabola wouldn't cross the x-axis. So actually if we take this one, we could see that it doesn't cross anywhere on this x-axis, because here's our x-axis and you can see that parabola is never going to touch it. Okay, so using the discriminant really helps us because we don't have to go through the whole quadratic formula to find that there are no roots. Okay, now if you end up that a discriminant here equals 0, it means you could probably factor it, okay, because it's a perfect square. Okay, so some questions here for you to do tomorrow in class, so have fun.